In this lecture, we will talk about the example here. For the polynomial function f of x equals 3x squared plus 48, we want to find the remainder of f of x divided by x minus 4i, and I here is an imaginary unit, and here we say is a complex number. Okay, this one. So that's the feature of this example. Recall radical negative 1 is I, so is I squared is negative 1. Okay, is like what? 4 choose radical is 2, and then 4 equals 2 squared. Okay, so the same thing, similar thing. Okay, and here we want to use the remainder theorem to find out the remainder if this polynomial 3x squared plus 48 divided by x minus 4i. Remember, if here the exponent is 1, then we can use remainder theorem. Okay, you can directly plug in 4i, this number, into the polynomial. You shall get the remainder. Okay, x minus 4i. So then you plug in positive 4i. Okay, if here were plus, then here would be negative 4i. Okay, so again, 3x squared plus 48, this polynomial divided by x minus 4i, then the remainder is f of 4i. Or simply we say you plug in 4i here, you should have the remainder. Alright, so let's plug in 4i into this polynomial. So replace x with 4i. And then 3 times 4i squared plus 48. So you replace x with 4i. Remember, square goes to 4 and I. Okay? And then, 4 squared is 16. You keep 3. And I squared, we reviewed, is negative 1. And then plus 48. 3 times 16 is 48 times negative 1, so it's negative 48 plus 48 is 0. So the remainder is 0. If 3x squared plus 48 divided by x minus 4i, then the remainder can be found by plugging 4i into it and then find out the value. In this way, you have the remainder. Here it tells us that the remainder is 0. So basically, for this question, finding the remainder, you can just simply do like this, and then you are done here. You are done here. All right. Now, let's let's do something more. There is an optional way to find the remainder is by using the synthetic division. The synthetic division works in this way. 3x squared plus 48, and then the coefficient of x is 0. So when you do the synthetic division, you want to have a 3, exponent is 2, and 0, the coefficient of x is 0, 48. That's a constant. So you want to plug in 0 here to do the synthetic division. Okay, and then again, if here is minus 4i, you want to put 4i here. Recall the algorithm is this number 4i times 3, and you put it right here. So 4i times 3 is 12i, and add those numbers together. 0 plus 12i is 12i. Again, 4i times 12i is negative 48, and then you add together is 0. Why 4i times 12i is negative 48? The details are here. 4i times 12i is 4 times 12 is 48. I times I is I squared. Again, I squared is negative 1. So negative 1 times 48 is negative 48. That's how we get that. You add together, you have a 0. So this spot is the spot for remainder, which is 0. Is consistent with the one right here. And here is the quotient. Okay, is the quotient. So what is the quotient? The quotient is 3x plus 12i. Basically, you can pull 3 out, and then 12 is 3 times 4. So if you pull 3 out, you have x left over, and then plus 4i. Okay, so then the original polynomial can be written as the quotient, which is 3 times x plus 4i is the number right here, times the divisor, and then plus the remainder. Okay, yeah, you know, recall, let me put something extra here. It's like what? 7 divided by 3. You do like, you put 2 here. 2 times 3 is 6. And then you do subtraction. Okay, so you have a 1 here. Then you know 7 can be written as what? Quotient 2 times 3 plus 1. That's the remainder. Okay, so it's like here. Here is the quotient. Okay. And here is the divisor. So, and this number is the remainder. All right. So please review this lecture, and then I will see you next time.